So you may have heard the term zero trust architecture, but what really does that mean? Basically what it means is that even within the walled gardens within our environments, some of our internal networks or our DMZs within our environment, we should treat those as if they're exposed to the internet. So you may feel that that's a little bit weird, right? Why am I treating my internal resources as if they're on the internet? Well, it's kind of that old theory that everything's secured on the outside, but it's all a bit gooey and soft on the inside, right? So you should always assume breach and assume that somebody has broke through your perimeter and is inside your environment. In which case, if they get in, we want to make sure we're doing things such as least privilege and making sure resources have only got access to the things that they actually need to have access to. Because if not, if somebody cracks through the perimeter, then they've got a foothold in your network, and if it's all soft and gooey inside and you haven't really got tight practices, they can start moving laterally and doing some pretty bad stuff. So we want to make sure that we've locked down our walled gardens in the same way that we would lock down our resources that are externally facing the internet. One other way to think about it finally is that if you were building a castle today, would you protect it with a moat, or would you do some alternative protections that are a bit more advanced? Well, you'd probably do the more alternative protections and have some security inside as well. So think of it like having security as if everything is connected to the internet.
Hey everybody, it's me, Jay Gordon. Welcome back to AzureFunBytes. So thankful that you're here to join me once again. What do we do every week? We get together and we talk about the products, the people, the different service, the complementary services from other vendors that make up an amazing Azure experience. This week I'm back. Last week we had the well-architected video show that was on Learn TV, and I wanted to be able to give them some space. So I went ahead and took a step back, but I'm back this week. And one of the great things that we get to talk about is, once again, security. We've touched on security a bunch lately, and I think that it has been really, really interesting. We have consistently tried here on the show to give you good practices so that you're set up for success, because I think one of the things that I've kind of hit upon is that we want to ensure a secure internet, not just for what we do, but for the other people that we're providing products to. We want them to feel good about what we do. We want them to feel good about their reputation of their businesses when they're using these types of products and open source projects. All of it is just super important. So today I've got some really great guests. I've got two guests from a really interesting company called WhiteSource Software. They were kind enough to make this about today. So it's Rhys Arkins and Lena Kleyner. I'm super happy to have them here. But I want you to kind of take a look at this first. We're going to just go ahead and get an idea of what exactly WhiteSource does. So let's take a look.
Software development today relies on open source components to deliver the capabilities you want at the speed you need. But verifying that the components in your app are secure and compliant with your policies is not that easy. Information about open source vulnerabilities is scattered and constantly changing. Securing and verifying the compliance of each component by yourself will slow down development, but doing nothing will leave you exposed. Either way, you suffer. There must be a simple way to secure and manage your open source use. With WhiteSource, there is. WhiteSource automates the entire open source management process. It enables teams to use open source freely without compromising on security or agility. WhiteSource continuously identifies all open source components in your app. It detects any vulnerabilities in real time and enforces your company's policies, whether your app is still in development or already up and running. It even prioritizes vulnerabilities based on if the vulnerable method is called by your application, so you can focus on what matters. WhiteSource also makes life easier for developers by detecting issues directly inside their environments. This helps them make better decisions, speed up integration, and fix problems quickly. Now you can be sure your applications are secure, as WhiteSource detects and remediates vulnerabilities even post-deployment. Join the WhiteSource revolution and start using open source freely and fearlessly.
Well, I think that gave you a little bit of context with what we're doing and what we're talking about today. So here's Rhys and here's Lena. Hey, both of you, thank you so much for being part of the show today.
Hi, Jay. How you doing?
Hi.
I'm doing. So I am so lucky to have you both here part of the show. I think that security, like I said, it's been one of the more interesting things to have conversations with people about, only because it is so paramount. It is so much a thing that's not just one person's problem. It's everybody's thing to kind of concern themselves with along the software delivery lifecycle. And I think it's super important. And I want to ask our viewers today that if your organization has a standard test suite, let us know. We head over to aka.ms/learntv, take our poll, let us know. And one more thing I want you to check out is that you can go to Microsoft Learn for free Azure education. As you can see, it's all gamified, and right here we have XP. I am a level 10 Azure wizard. As I like to say, I need to get some more points and hopefully learn a little bit more. So enough about what I'm doing and where I'm doing it. I really want to talk to you two. And so there are so many amazing things that are going on around the internet or I should say in software development to help people have a more secure process that goes into delivering what they're working on. And we'll talk more about that. But before we do, I want to learn a little bit about you two. And I think that that's always my favorite part because I love talking with people. And so, Lena, you're in, if I'm right, Israel?
True.
So you want to talk to me about how you got here? And when I say here, I mean, this crazy world of technology.
Wow, I think from young age I was attracted to technology, and prior joining WhiteSource, I was a developer, so it's really an exciting world to join. And in WhiteSource we design products and tools for developers. So I think that after being on the other side, it's much more easy for me to relate to the needs and requirements of developers.
Okay, great. I thank you. And Rhys, where are you located out of?
Hey, Jay. Yeah, I'm an Australian, but I'm based in Stockholm in Sweden.
Oh, I love Stockholm. I haven't been there since I think like 2019. We did a Microsoft Ignite the tour there. And I am so thankful for the music that comes out of that part of the world. Very, very big fan of Swedish music. Mostly their death metal, but that's a whole other conversation.
Oh, right. Our producers are pretty big too, actually.
Yeah. So Rhys, why don't you tell me a little bit of the same information? So tell me how you got here.
Yeah. Great. I mean, so one thing Lena left out was that I've dragged her onto the show to help me out because I was too chicken to do it all myself. But my story is I kind of classify myself as an accidental security professional. Had kind of 3 different phases of my career, this is the third one. And in all 3 phases, I started out not thinking I was working in security, and I ended up working in security. So in this last phase, I just was scratching an itch. I built a kind of like a DevOps automation tool. And it got popular and people started using it. And it made a lot of sense for it to kind of join a bigger company. And I'd been working alongside WhiteSource for some things. So they convinced me to join, bring the tool. And so it was a dependency automation tool. And of course, the most useful reason to automate dependencies is for security reasons. So then I found myself in security once again.
Wonderful. So it's great to learn a little bit about the both of you. One of the things that I want to kind of bring up really quickly is that you've got a bunch of implementations, or I should say ways to implement Azure products alongside WhiteSource. I think my first introduction to it was working with the people at CodeFresh. We did a containers deployment workshop, and we used WhiteSource to do the scanning as CodeFresh did the CI/CD portion of it. And I thought it was really interesting. As you can see, we've got a WhiteSource for Azure DevOps implementation that you can use. There's a bunch of other products like WhiteSource Bolt, the Renovate Bot, which we'll talk a little bit more. And of course, we've spent some time at Microsoft letting people know how to learn more about this product. And so you can see there's this great blog post that was done a little while ago. It's about streamlining application delivery and development with Azure and AKS. Great products. And so that being said, I think it's worth it to kind of get started and talk a little bit about our subject at hand. And so I'm going to give you both a little bit of room to kind of tell me a little bit more about WhiteSource and how we can best secure open source software.
Great. I might lead off. That's right. So as you mentioned, there's lots of areas of security. It's pretty interesting to talk about. I liked actually how you had the video at the start on zero trust with security, because zero is a really important number when it comes to open source, because in most areas of security, zero is a fantastic target. You know, like you want like zero attackers in your network, you want zero secrets committed to your repositories. You know, in general, you can have this approach of our goal is zero, and when we don't get zero, you know, we can work out what went wrong, change processes if necessary, and keep iterating until we get to zero. Why open source is a really interesting security aspect to me is because it's basically unrealistic to get zero vulnerabilities in open source. And that's just because we use so much open source. And some of the problems in open source are very hard to find. It takes, you know, like a very talented security researcher. That the reality is, to get zero vulnerabilities in open source means basically not using open source. And it changes a little bit, because instead of aiming for a posture where you never have a problem, you know, always just trying to, you know, check everything before you do it, double check it, triple check it, like succeeds in many other things. You can't have that unrealistic goal in open source. It's got to be a balance of prevention, but also very rapid cure. It does make it quite different, because you basically have this assumption from the start that you're going to have problems, and your planning needs to be part of how to react when problems are there and how to prepare for problems, not just, oh, if we just get better and better, we'll never have a problem.
Gotcha. And I think that the reason I like to bring up that zero trust video beforehand is that I believe that in order for us to kind of take the best posture, we need to consider everything is hacked. Everything has got some sort of intrusion, and work from the inside out, if you will. Start looking within your software and your products, rather than allowing, you know, out other sources to kind of let you know. I mean, you can do things like penetration tests, but today we're talking a lot about security scanning before you get to the point of going into production. And so, Lena, do you want to tell me a little bit more about how WhiteSource helps people do this?
Sure. We have a variety of tools, but basically the fundamental part is that they all are scanning your development project, your code, prior the deployment or after build, or depend on the level where you are interested to perform this check, and give you an easy and intuitive way to see and manage your open source usage. So we give you a way to see the inventory, the list of open source components you are using, and also telling you about any risk that maybe that we identify for these open source components. We also give mitigation options, fixes, and maybe, Rhys, you want to take it, automatic pull request and things like that.
Sounds good.
Yeah.
So, is there kind of like a triggering methodology on how to like? I know we're going to look a little bit more. So, does WhiteSource use kind of like a repo triggering methodology in order to know when to begin that process?
Yeah, great question. So one of the things about security is that if not done well, it can slow down development. So you saw, thanks for showing our homepage. You know, one of our slogans is prevent the preventable, remediate the rest. Another one that we talk about, as CEO often says, is security at the speed of development. And what we're trying to get at is that we don't want to slow down development. One of the things any security company needs to understand is like, you are not the primary purpose of your customers. You know, your customers are building websites, making, you know, like live streams, you know, doing lots of things. Security is not the primary goal. It's a necessity, and professionals understand that. But you should not, you know, not think that the number of hours a week or a day that you can get your customers using your product is a metric of success. So for that reason, we try to bring security to where the developers are, rather than expecting developers to kind of work their way into our workflows. And that's why with platforms like Azure and Azure DevOps, we really want to provide as many touch points as we can into the developer workflow, because something that's more seamlessly integrated with the regular workflows, it's much more likely to be accepted, adopted, you know, if you maybe even liked, you never know. But the point being that you don't want it to be forgotten, you don't want it to be detested. So yeah. So for example, the general thing you want to do is scan every commit. And the type of scans you do might depend upon the situation. It depends upon the type of software you're building. But as an example, when you have pull requests, the goal of a pull request, or at least the goal of any checks on a pull request, is to make sure it doesn't make things worse. You know, so it's like a gating check to make sure you're not introducing problems into your project. And on the other hand, when you go to deploy, then there may be like other checks, which, for example, dedicated compliance or security teams do, like maybe a much more deeper check, where they want to kind of make sure that they're 99.9% sure they're not shipping something with a license that's, you know, not okay, or things like that. So there's various stages in that software development lifecycle where you want to try and help people out, either to catch a mistake they've made, or ideally to like preempt it.
Gotcha. Well, you know, that's all really important information. You know, the more we put, and I hate always having to use this term, but the more we kind of shift left in the software development lifecycle, what we'll do is give people the priorities to ensure that security is a part of what they do when they start writing new pieces of software. They'll want to consider, all right, is this particular package that I'm going out as a dependency, is this safe? And so these are the things you kind of have to consider, you know, with things like NuGet and say NPM. You know, they're great ways to build software. They're really convenient, but nobody wants to go through a situation where your end users are having Bitcoin mining done on their computers because there's been something injected into an NPM module that you happen to be using. And so I know that you do a lot of detection, prioritization, and remediation. Do you want to talk to me a little bit about how that works?
Yeah, Lena, you want to start off on the detection part?
Sure. So the detection is done on the code, on the development project that we want to scan. So basically, we have all kind of agent that will scan your code and try to identify the dependency, the open source dependencies that are used by the code. And basically, what we will do is generate a fingerprint for each such component. And then this fingerprint will be matched with our with WhiteSource database of all open source fingerprint, and which includes all kind of information, the license information, and all the security vulnerabilities that were identified for these components. And basically that's how the scan, as a general overview, is performed, the detection part.
Yeah.
Great. So once we've done the scan, yeah, I was just gonna say, once you've done the actual scan, let's talk about the next part, because I really like that little, and I'm gonna bring this up really fast. I really like this little pyramid that kind of goes through these 3 big steps. At the lowest point, the foundation is detecting these issues. Then the next part is prioritization. Do you want to talk a little bit about that, Rhys?
Yeah, thanks. I was about to jump into that before, but thank you for bringing up the pyramid there. So yeah, so detecting is one thing, and this is like many other areas of security. You don't always have the time to solve every problem. You certainly don't have the time to solve everything sort of instantly. So prioritization is very important. The best type of prioritization you can actually do, though, is to like fully triage an issue as being able to be ignored. That's actually the best that you can do. And so in the video you showed earlier, that was one of the kind of key strengths we have. And it's got different names. You can call it effective usage analysis or reachability analysis. The idea of this is that, we've detected you have 1,000 dependencies you use, and maybe you've got 10 vulnerabilities, especially if you're starting out. Now, what actually typically happens is that maybe 8 out of those 10 vulnerabilities that have been detected, they exist in the file system, you could say, but they exist in lines of code that will never be touched by your application, because sometimes a library can do like 100 things, like a Swiss Army knife, and you might be only calling 2 or 3 of them. So if there is a vulnerability in one of the other 97 functions, that's not truly a vulnerability to you. So that prioritization step is really critical to reducing the workload by, up to, whether you flip it, 20% is valid and 80% is unreachable. It's 5 times less work. And that's a real critical step in the prioritization. I also believe it's a really critical step for just getting developer, buy-in, because one of the worst things that happens if you're, like I said, your primary goal is to build software, not to do security. So
sure,
but you get told that you need to drop everything to fix some vulnerabilities, and then you dig down into it and you realize through manual work that this code is just never used. This is like you might call the false positive even. So being able to prioritize them out, it works sort of in 2 ways, because it enables you to focus on what's important, but it also means that you don't lose trust in the software organization, that you are, giving them things to chase that aren't really problematic.
Gotcha. Well, really, really interesting. So we've been talking about the pyramid and these different kind of pillars to bring you into some form of compliance. And the last one in the pyramid is remediation. Which one of you wants to kind of pick up?
I'll take that one actually, because I actually helped write some of this one. So yeah, so remediation was then a really logical step for for open source security. The first step was companies like WhiteSource working out how to detect what you've got, cross-referencing that against known problems, and then you would often get a recommendation, like a fixed recommendation. This library has a problem, updated to version X. And the thing was that concept of update to version X, a lot of the time that can be automated. And so, the difference between giving someone remediation advice versus actually remediating it for them automatically in a pull request is pretty big, because, of course, people could ignore advice, or it's extra work to do. It saves them the work, but also it reduces the chance of human error. Because actually it might sound simple, update to version 1.0.0, but you know what, it might pull in other files and you have to make sure you committed everything that was needed. So just to reduce that human element, the possibility of error, and give people what is often a one-click solution is pretty powerful for helping people. So narrow that down from 10 to 2, then automate the last 2. It starts looking a lot better than say 5 years ago in this type of thing, where even the people who are on the cutting edge were still having to manually update or patch 10 vulnerabilities out of 10 instead of now automating 2 of the 10.
Gotcha. Well, I know you've got a little bit to show me, and I'd love to kind of see what it is that you brought along today. And while you get your screen ready and all that stuff, I want to go ahead and remind everybody there's a poll today, If you don't mind, I'd love you to go and take it. Go to aka.ms/learntv, and you can answer the question, does your organization have a standard set of security tests for your deployments? It's real simple. Go to yes, no. And then also, if you see, we've got here docs for today's show, including links to all the different WhiteSource material that you could check out. So all on the right rail there. I really suggest you go and check that out. So I'm going to bring up Rhys's screen, and I'm going to give you a chance to kind of explain what your how open source security and WhiteSource work together.
Yeah, thanks, Jay. So I assume you got my screen right now. So I prepared about 5 slides here. I just wanted to pick out what I think are some of the highlights. Your questions so far have been really fantastic. So we've covered a little bit of this ground, but one of the key things to understand why open source security is important is that in the ballpark of 60 to 80% of an average application's code is comprised of open source. So people sometimes think of that as like, the iceberg, like what you see above the water and what's below the water. So what you might think of above the water is like your own code that you write, but the reality is like a huge chunk of that that is actually running in production is coming from open source. You might be familiar. There's a saying I love. People say like, you don't want to know how the sausage is made, or they say don't tell them how the sausage is made. The reality is, though, if you're in the business of making sausages, you really do need to know how your sausage is being made. And so that's similar with software. If you're in the business of making software, you need to know what's going into it. These days, you can't just kind of say, well, and there's a bunch of stuff some other people wrote, and I assume it's good. That no longer kind of cuts it. So breaking down like open source and security. So one of the things is that open source is not inherently more secure. Originally, people thought open source is like very insecure. Some people say it's more secure because it's open. The reality is just publishing something to NPM, or to a NuGet registry, that process itself doesn't make anything secure. What is different is that open source is inherently more securable as long as someone's paying attention. And by being out in the open, it means that companies can kind of audit, inspect it, check it, and things like that, which is something that you can't usually get when you have like a black box kind of closed source code. On the other hand, open source is very highly exposed to attacks because you don't need any permission or check to publish open source. So no one is stopping you putting packages on, again, these same registries. Just like no one really stops you like uploading like a script to GitHub or Azure repos that has malicious code in it that like copies the environment and posts it somewhere else. So it's very exposed in that sense that there's no gating to stop bad behavior. The other point is that open source is highly leveraged. So if you were to successfully infiltrate, like you mentioned before, like for Bitcoin mining or something, if you can infiltrate open source packages, you can leverage that attack very widely. And this is why open source is considered a great target, unfortunately, for what we call now software supply chain attacks. That idea being that you kind of insert an attack somewhere in the chain. It's almost like putting a bottle in the stream and watching it go down the stream. They wait for it to go down and multiply and then see where they got in. So they're not they're not trying to target, say, Microsoft or WhiteSource, but if one of our suppliers, one of the packages we use got compromised, then we'd be at risk.
And there was a great article that I read on VentureBeat recently that said next-gen software supply chain attacks have been up like 650% in 2021. Yeah. That's a lot of percent. It's pretty wild to think how deep that rabbit hole is going. It's just a very, very huge number, a big increase, and more things for people to be concerned with.
Just to give you like a figure, in this week alone, WhiteSource has reported to NPM, the registry. We've reported 58 unique packages with malicious code that have been removed from the registry in 1 week. There's a lot of attempts going on.
Yeah, it's definitely a concern. I think people should put at the forefront of their software development when they are considering releasing something into the wild, because once it goes up onto GitHub as a public project or something like that, you're introducing people to your code. You're socializing that code. You're making it available to people, and you can only hope that everything you've done from the get-go is going to keep them in a good position where they're not going to have to be concerned about an intrusion based on a bad package. So I think this is really interesting to learn about.
All right, so because this term software supply chain comes up a lot, I try to kind of describe it here. And one of the things I tell people is that actually the real truth is that no one really talked about software supply chains much at all until there was a security problem, so like, because we all wonder, well, what is a software supply chain? Why didn't I hear about it? It's like, well, because it wasn't really a thing until we needed a way to describe the security threat. And actually a company's software supply chain, it's a very wide net. Like a company's software supply chain consists of any component, any third-party component, like you didn't write, consists of any third-party component which could be used to compromise the final product. And I hate, I'll touch wood, but as an example, if there's, our joint customers using Azure, using WhiteSource, I mean, everything from the laptops they develop on to Azure DevOps, Azure repos, to WhiteSource itself are all an element of the supply chain. So it's certainly not like an easy problem to, to stay on top of.
Understood.
So then just a final point, talking about, software supply chain and then open source, because, we are really focused on open source at WhiteSource. Open source risk does need to be managed very carefully. It is the largest component in the software base, so it's the most number of lines of code for nearly every project, and it's the most exposed or uncontrolled. Unlike your software from, sort of Microsoft and WhiteSource and companies like that, like it's not easy for someone to get in and add malicious code to it. Just by the way, everything we've been talking about falls under this idea of software composition analysis. It's kind of like that's the analyst term for what companies like WhiteSource do. We analyze what your software is comprised of, and in very short terms, what that is you got to know what open source components you're using and know if something is wrong with any of them. So in my point of view, like, as a vendor, the perfect thing you can do is give your users, your customers, like a feeling of safety, a feeling that, okay, I mean, it's not necessarily possible to be perfect, but we've got like a great partner, a great vendor who, will tell me when there is a problem. Like I'll focus on what I'm doing, but when they tell me I have to, focus on the problem, I will. But, I don't want to be awake at night wondering if they're actually, if there's a problem I'm not aware of. So that's the best thing that we can do as a vendor.
Sure. That's great. So I want to remind everybody, if you've got any questions, throw them in the chat. Use whichever chat that you're currently streaming this show from. There's YouTube, there's Twitter, there's Twitch, and of course, if you're watching on Learn TV, you can go ahead and share from there. I'd love to kind of see a little bit more. Lena, what would you like to kind of show here?
Yeah, so I will demonstrate today our native integration in Azure DevOps. So let's start with reiterating on what we're trying to do. We want to give an easy view of the open source usages and to expose any security or compliance risk that are linked to them. And we want to do that in the developer native environment. So for that purpose, we developed an integration with Azure DevOps. And basically, we have two extensions for that. One is for the WhiteSource customers, the extension that we see, WhiteSource for Azure DevOps Services, very highly rated, Jay, as you can see.
I'll be sure to go in there and give it an upvote.
Please do. After you see how it performs, I'm sure you will want to do that. So this is one extension, and we have another extension for our free users, which is available for any Azure DevOps user. Okay, so let's try to see how it works. So when I press get, I install that and activate the installation, the extension, sorry. So if I enter my Azure DevOps organization, I see that I have already installed that. So let's see the extension, what we can do with that. So we've created a demo project, which will be loaded shortly.
Mm-hmm.
Okay, so this is a simple NPM project. Let's look at it. Okay, very simple NPM application. And let's say I'm using let's look at the package JSON just to see that I'm using two dependencies. So let's start by creating a pipeline, a build. I see that this repo does not link to any CI/CD. So let's create a new pipeline. We'll see here the creation of a new pipeline, but what we'll see in regards to the WhiteSource task will be easy to be added for an existing pipeline. So this is an Node.js project. So we'll use the Node.js template, and basically the basic template is good enough for us. And after the build phase, basically after the application is built, we would like to have a WhiteSource scan. Okay, so let's open the assistant and search for the WhiteSource task. Okay, we'll see here WhiteSource task. We can define the project name. Let's say I call it npm demo 1. This is not mandatory, but let's do it anyhow. So we'll see a WhiteSource task was added to our pipeline. So let's save and run that. Let's commit this change to the main branch, save and run. And basically what will happen from this step on is that we'll have the Azure pipeline YAML was created, and it also triggered a new build. And the build is doing some initialization steps, creating an instance, building the project, and then running the WhiteSource task, what we just discussed before, scanning this project to identify all the open source components and to map them to our database with all the information. So we see that the build has finished or not.
Well, while it's building, I can ask a question from our audience. So Akichi, or I hope that's how it's pronounced. If I didn't pronounce it right, please forgive me. Do you have to install WhiteSource from the marketplace first? Is their question?
Yes, in order to be able to add the WhiteSource task, you need to have the WhiteSource extension. So we see here, the example that we just seen is the WhiteSource for Azure DevOps Services extension, but a very similar UX is also for our second free extension, which is called WhiteSource Bolt. So yeah, you need to install that.
Very cool. And if you want to check out WhiteSource Bolt, I've got this quick link that you can use, cda.ms/2lf.
Cool. So our build is finished, and now we're logging into the WhiteSource application. And what we can see here that following the build that we just ran, there was an analysis made by WhiteSource to identify the security risk and the license compliance risk. But basically, this is the WhiteSource application, and the persona that this report was designed for is the security persona who wants to understand and see an overview of the risk identified for the development projects that he has managed. But we basically wanted to build something that is more developer focused and more and more fit to what developer needs, which is something that will highlight the security risk, will suggest ways to mitigate that, but most importantly, will not require the developer to leave his native environment. So if we'll go back to our pipeline, we'll see that we have next to each build, we have a WhiteSource tab, which basically now it will load, and we'll see a very similar report, which indicates the scan results. So what we can see here, the total number of libraries, but what is important here is a security summary. The vulnerability risk, it can be high, low, medium. In this case, this is high because high security vulnerabilities were detected, the number of vulnerable libraries, and the severity distribution of the vulnerabilities. We can see here several important tabs, the entire inventory, which means the entire list of open source components and their respective licenses, and a suggestion of a list of all the outdated library with a suggestion of the newest and stable version to which it can be upgraded. And of course, the security vulnerability in a more detailed report includes the severity, the vulnerability ID, the library, this security vulnerability if relevant for, and a top WhiteSource fix. In addition, we can see a compliance analysis. So in this case, we can see that we have identified a medium risk because one of the components that are being used by this development project is a LGPL license. So let's try to following this report. Sorry.
No problem.
To try to mitigate the risk. Okay, so as you remember, we've seen that we are using the Express library, and Express library has its own security vulnerability relevant to it. And if we try to look at what the suggestion guides us to do is guides us to update to one of those versions. So the most relevant version in this case, because we are using version 4, is to upgrade to 4.5. So let's get back to our repo and update the package JSON. So let's update to what we've just saw and were suggested. We'll commit the change. We'll commit it to the main branch, just for the ease of the demo.
Sure.
So once we've committed that, what will happen is a new build will be triggered. We can look at the pipelines. So we see that a new build was triggered. We see that the build is in progress.
And there we have our build there.
And Jay, one thing I'd like to point out here. So one of the things we did in this demo is to use a package JSON. We picked npm. You may have spotted, if you have an eagle eye, we don't have a log file in there. Now that was partly because we wanted Lena to be able to update things, easily during the demo. But it serves another purpose because I'm going to reuse that iceberg analogy again, because all that you actually see in this repository is the direct dependencies, but it is important from a compliance and security point of view that you're also aware of your indirect. So what the WhiteSource plugin has done is actually resolved all of the dependencies in what we call the dependency tree, and it's telling you about vulnerabilities in them. That's what Lena is about to show now.
Gotcha.
Exactly.
And just to let you know, we got about 14 minutes to go. I know time is just flying by, and there's been so much you've been talking about. So I just wanted to remind you of time. And if you're watching, that means you've got 14 minutes to ask your questions. Go ahead, Lena. Sorry.
Okay, thanks, Jay. So I'll try to increase my pace. Okay, so although we had only one security vulnerability linked to the direct dependency, as Rhys mentioned, to the Express, although we updated the Express version, it seems that we still have security vulnerabilities, and the reason is, like mentioned by Rhys, because we are performing a deep scan, trying to identify the entire hierarchy, dependency hierarchy tree, and because Express itself comes with other dependency of its own, and they have security vulnerabilities as well. So this is what we see in this case. So let's try another time, and let's maybe try to upgrade to the newest stable version of Express. So
Okay.
we'll do the same thing again. We'll go back to our repo, update the package JSON 71, and commit that. Once again, a new pipeline should have been triggered, a new build, should have been triggered as part of our pipeline following this update. And yet again, it's working. The job is initializing. I'll start building our demo project, and then running the WhiteSource scan.
When it comes to developer tools, we aim for two critical things. One is automation. If you don't automate it, it can get forgotten. And the second is to minimize context switching. And so that's why, as Lena showed earlier, while we do have views in our main application, particularly for like the security, lead, we wanted people who work in Azure DevOps to be able to stay in Azure DevOps as much as possible. So that's this kind of combination of these two things we're showing now.
And this is also available to work within GitHub Actions. Am I right?
Yeah. So we also have an application for GitHub.com as well.
Great. Very cool.
So here we go. We see that our final change has removed the risk altogether. We have 0 vulnerable libraries, 0 security vulnerabilities, which is great. However, like we said at the beginning, this is not a real-life project, and in real-life project, it's really hard or almost impossible to remove all the risk. So we need to find ways to prioritize, and there's many ways to do that. So just one more last thing. We have another extension for free users, very popular one, with the same UX as we saw, with the same report produced as part of the Azure DevOps pipeline. And also, I would like to mention that once a user installs this extension, it enables a free 30 days trial of WhiteSource Application. It's a lightweighted version of WhiteSource Application with a new and advanced UI and more functionality like exporting and so on. So this looks like that. I'll stop here for questions.
Sure. Let me see if you're in the chat, anybody, and you'd like to ask a question. I'll feel free. I have one question, if you don't mind. I know that there is a product called, is it Different or Defer?
Defend.
Defend.
Yeah.
Do you want to just give me like a quick idea of what Defend is?
Yeah, I'm happy. I had a demo prepared on that. I don't know if we get time to it, so let's just. Defend is designed to address the supply chain security aspect in particular. It's what it does is it's something that runs in WhiteSource infrastructure. It scans real time. It scans in near real time all releases. So when something gets published to like Ruby gems or to npm, it learns it right away and it scans it. And it scans it with many different what we call heuristics, not just about the code, but also about who published it and some of the things like that. Is it using a suspicious version number and all that type of stuff? And so what it does is it uses automation to flag packages as being suspicious or not. And then we have a security team which investigates those as quickly as possible and confirms whether they are malicious or flags them as kind of, maybe badly designed, but still not malicious. And so Defend is essentially the engine that that triggered that 58 packages reported to npm in 1 week alone. It's just constantly scanning, looking for bad stuff, and it's also part of the the WhiteSource portfolio, including for people that use Azure DevOps.
Very cool. And so I have one more product question. I know that there is a bot called the Renovate Bot. We only have a few minutes left, but I'd love to hear a little bit about what the Renovate Bot is.
Yeah, if it's okay if I'll share my screen and just quickly run through it, because this is part of the remediation aspect that we spoke about before. So Renovate at its core is an open source project, which you can see here. It's had hundreds of contributors, including many outside WhiteSource, and then we also use that a lot within our own products, including remediation. If I take an example here, so I'm using a log file because I wanted to show that we can chew gum at the same time. I'm also using Express, but I've used another one called Chalk here. Now, to install npm is actually very, very simple. It's npm install global renovate. So I've already got it installed, and my repo name here is Rhys npm3. So to show, I have configured the platform, the endpoint, and the token already. That's it. So I basically said,
that's easy.
Azure, my username you can see there, and then a token which got an end, and it is running. And what we're going to see back here first is what we call an onboarding pull request.
Okay.
All right, configure renovate, and so this lets you kind of like decide if you're happy with it. So you can see that there's 3 updates pending. We can even dig down for some details of those if we want. Let's say this looks good, so I'm going to complete it. I like to squash commit. Good. Okay. So at this point, what just happened was I committed a config file, very basic here. In fact, it's actually empty except for declaring what the schema is. We will run renovate again, and what we're going to see is those branches and pull requests that were created, that were forecasted. You could say they're going to be created here. Right, we already got one already. So that's Chalk 242. I intentionally did this before I knew I'd have short time, but you see here it says release notes retrieval was skipped because there's no github.com credentials. That's because most open source projects are hosted on GitHub, and to get the release notes, like change logs, you need to contact GitHub, and GitHub rate limits you if you don't have a token. So I'm going to copy that into my shell and run again, and you get to, come on. Okay. So basically what I'm doing is I'm using my own credentials to say I've got permission to just download release notes publicly at scale. And what we will see is this pull request will update and actually will embed those release notes telling me, there we go. So now you can see I don't have to go off and look at those. I don't have to drill down. It's all there. I can see exactly what changed in 241 and 242. Now as an example of things that you can do, we go back to the config, and I am going to enable something else, because another feature we have is called merge confidence. So this is done via essentially a plugin system.
Okay.
And it's called WhiteSource Merge Confidence. And I'm going to use the beta version. So I've now, did I remember? Okay, I hope I remember to close my, yes, I did. Okay, so we run again and we'll see that this pull request updates even more. We should have 3 pull requests. Yes, we go back to this one. And there we go. So you see what just appeared here? This is like a series of columns that tells me the age, the adoption, the passing, and the confidence. So the thing with the adoption, it's not really to be worried about because this is actually an old version. We saw before this version 4. So 19% is not to be worried about. It's 2 years old. 100% of people that tested this had automated tests against this version. It passed. So therefore it's high. So again, just playing, actually I won't do it. I'll complete it. Okay, because I wanted to show something. That did I do it? Please, yes, it did. Okay, so now we go back and we have 2 pull requests. One of which was upgrading Chalk to version 4. I'm not sure why, but you can see here it actually thinks there's no merge conflicts, Azure. But if I do say to complete this version 4, it will show me that there are conflicts because, of course, we just edited the exact same file and line that we're going to do. Now that would be annoying normally, but one of the features is that it does automatically resolve conflicts. So what we will see in a few seconds is that the existing pull requests get essentially rebased and the merge conflicts solved. And then we now have this. And so you see here it's a little bit different. Merge confidence in this case tells us it's 62 days old. Adoption is 19%, but passing was only 81%. And that is because this was a major release update. And so major updates can sometimes have like breaking changes. If we scroll to 4.0.0, we see there was a couple of breaking changes. Node 10 changed the level. But the one that actually caused most of it was actually here in version 3. You can see that they well documented some of the changes. And so normally what I would go and do is to check my code. If I need to make any changes, I add it to the branch and then it would merge. And if we go look at the other one that we had there, it was our friend Express. And so Express, that was the one Lena was working on. We can actually see the latest version of Express, actually 2 years old, 74% adoption, 100% passing. That is very high confidence. And so that's the type that I'm going to happily, complete. So this is an example of using automated pull requests. And just to show you an example, it's not just like the package JSON. As we said before, you have, as I said before, we've got log files as well. So you can see like there's a massive complex changes to log files that have also been provided here automatically. It removes that that human element, that possibility that people could make mistakes. So this is part of the remediation part. And last thing I'll say is actually coming up end of year, we're actually combining these 2 things we demoed today, the detection and the remediation, with a new app for Azure DevOps. And that'll mean that actually there'll be automatic scans and automatic pull requests, assuming that that's what you want and you enable that feature.
Very cool. So we're going to wrap up. Our poll went very well. 19 of you voted, and 53% of you said that there are a standard set of tests. That's really super important. So I want to just go ahead and say thank you to you both. I really appreciate your time. Lena, is there a place that we can find you on the internet or any way we can get in touch with you if needed?
Yeah, sure. In the WhiteSource software, I can be reached.
Okay, fair enough. And Rhys, I see you've got your Twitter there.
Yeah, I'm fairly active. So Twitter, GitHub, Azure DevOps. I'm on all of those. Pretty easy to find, including my email address actually.
Very cool. Well, thank you both for being part of the show today. I really appreciate it. And if you haven't yet, please go to the WhiteSource software website. Check out all the useful docs that we have for today's show. You'll be able to find more. Until then, let's give everybody the big wave goodbye and tell you, everybody, we'll see you next time. Thanks for joining me, Rhys. Thanks, Lena. I really appreciate it.
Thanks for having us.
Bye now.